Okay, problem number 29 on section 3.5, we get two equations and they want us to write them in slope-intercept form, and that's y equal mx plus b, slope-intercept form. And the reason they want us to do that is so we can look at the slope, because we're going to be comparing slopes in these problems, and it says compare the slopes in the y-intercepts and determine whether the equations are consistent or inconsistent. Consistent, if you remember, means there is a solution. And inconsistent means no solution. And another way of saying that is to say the lines are parallel, okay? So it's parallel lines. All right, so we're going to have to solve each one for y, because remember, to put something in y equal mx plus b form, what we really should think when we read that is solve for y every single time, okay? So I'm going to take the first equation, I'll do it in red. 3x equal 4y minus 4. Okay, so if I'm going to get y by itself, I could add 4 to each side. And I'd have 3x plus 4 is 4y. I'm going to go ahead and write the 4y over here and the 3x plus 4 on the other side. Now if I want to get y by itself, I need to divide everything by 4. So I can tell that my slope in this equation is the number in front of the x. Remember, I can look at it that way. It's 3/4 times x. We could write it that way, plus 1. Okay, so that's the first equation. Let's look at the second one. It's not going to take quite as much work. So I have 4y equal 3x minus 3. And I want to get y by itself to put it in slope-intercept form. So I'll divide everything by 4. And I'm going to get y equal 3/4 x minus 3/4. Okay, so the slope over here was 3/4, and the slope over here was 3/4. So they have the same slope, but they have different y-intercepts. Since they have different y-intercepts, that means they're not the same line. Okay, so they're not the same line, but they have the same slope. That means they're parallel. And if they're parallel, we call that inconsistent with having a solution. It's inconsistent with having a solution. There are no solutions, okay? So for 29, it's an inconsistent system. We'll look at 31 now. 31 is 3x minus 4y equal 12. And 4x minus 3y equal 12. And again, they want us to put this in slope-intercept form. And then we're going to tell whether it's consistent with having a solution or inconsistent with having a solution, okay? Inconsistent means parallel. Consistent means it has a solution, or at least one solution. All right, so I'll do these in different colors. I'll take the first one and do it in blue. 3x minus 4y is 12. If I want to put it in slope-intercept form, and remember the reason we're doing that is so we can easily compare the slopes and the y-intercepts. I'm going to solve for y. I'll move the 3x over by subtracting it for both sides. And I have negative 4y is equal to negative 3x plus 12. And if I want to get y by itself, I can divide everything by negative 4. And I get y equal, a negative over a negative is a positive 3/4 x. And then 12 divided by negative 4 is negative 3. So I'm just going to write it as 3/4 x minus 3. So what's my slope here? It is 3/4. Now let me take the second equation, 4x minus 3y equal to 12. Okay, we're going to solve that one for y so we can easily compare the slopes in the y-intercept. Okay, so I'll move the 4x to the other side. It's positive, so I'll subtract it or add the negative. It's the same thing. Okay, so 4x minus 4x is 0, and I have negative 3y equal to, let me write it in the form where I put the x's first, negative 4x plus 12. Remember, that's a positive 12 up there. Okay, to get y by itself, I'm going to divide everything by negative 3. And I'll get y equal, okay, so a negative over a negative is a positive, and it would just be 4 over 3x minus 4, because positive 12 divided by negative 3 is a minus 4. All right, they're not the same line. I can tell that. They didn't end up being the same line, did they? Do they have the same slope? Well, what's the slope on the second one? It was 4/3. Over here it was 3/4. these are not the same slope. Not the same slope. So what does that mean? It means that these are two lines and they're going to cross in some spot somewhere. And that means that they're going to have one solution. And so when you have a solution, you say that's a consistent system. That means it's consistent with having a solution. And we're just going to keep trucking on and putting stuff on here until I run out of time. 33. It says solve each system. Note the equations are not linear in the original variables. Okay. So here's the deal. Ignore that. Here's what we got here. We got 6 over u plus 3 over v equal 2. Okay. So what they're telling us to do in the instructions is saying let x equal 1 over u and y equal 1 over v. So we actually have to do that here. So how am I going to break this apart? What is this telling me to do? Well, 6 over u, do you agree with me that I could change that into 6 times 1 over u? It's equal to that if you look at it. If you multiplied it out, you'd get 6 over u. And 3 over v can be written as 3 times 1 over v equal 2. Now, if you look at this 1 over u is x, and this 1 over v is y, so what we have is 6x plus 3y equal 2. And they want us to try to solve this to find u and v. So here's one equation. Now I got to go do my other equation. Let me put this in a box just so I've got some room to work around it. Now the other equation they gave us, and I'll write it in blue just to kind of keep it separate over here, it was 2 over u minus 9 over v is equal to 4. Well, I could rewrite that. 2 over u could be written as 1 over u, and 9 over v could be written as 9 times 1 over v, and that's equal to 4. Well, if you look up there, 1 over u they said it's x. 1 over v is y equal 4. Okay. So I've got these two equations, and if I want to solve them, substitution doesn't look like it's working out so well. Let me go ahead and write these. I'm going to go ahead and go to a new slide because I know I'm not going to have time, not have a room to work this. Okay, so let me write these on a new slide. Plus 3y is 2, and I have 2x minus 9y is 4. And what I want to do is get rid of one of my variables, okay? I'm going to get rid of the y, and here's the reason. I have a plus 3y and a minus 9y, so I have the plus and minus going on, and what I can do is if I go through and I multiply the top equation by 3, it would be 18x plus 9y equals 6. Remember, you got to multiply every single term there. And if I just copy the other equation below it, 2x minus 9y is 4, you're going to see that that would cause those y's to cancel out. So sometimes we have to multiply one or both equation by something to get them to be able to add up to 0. And I was able to do that with the top equation multiplied by 3. So we're trying to get the same number out front of the y and opposite signs, and we already had the opposite signs. Now all we got to do is to add these two equations together. 18 and 2x make 20x. Those canceled out and added to 0, so I'm just not going to write 0 down. 6 and 4 is 10. So if I want to find out what x is, I divide both sides by 20, and I get x equal 10 over 20, which is a half. Now in a minute, we're going to go have to mess with this. This isn't our final answer, but I still need to solve this system. So here's what I'm going to do. I got x as a half. I need to find the y that goes with it. I have 2x minus 9y is 4. I'm just going to pick that one. The reason I did is if I plug in this x as a half, 2 times a half is 1, okay, minus 9y is 4, and if I subtract 1 from each side, I get minus 9y, because these will add up to 0, and 4 minus 1 is 3, so y equals 3 divided by negative 9, which reduces to negative 1/3. So we have x equal 1/2, and we have, I'm kind of do this so we can work a little bit more down here, y, I know I wrote those kind of reverse order, but oh well, equal negative 1/3. But the problem is I wasn't supposed to solve for x and the y. I'm supposed to solve for u and v, so I got to figure out what they are. Well, that's not too bad, because if y is negative 1/3, do you remember that y was also equal to 1 over v? So I could cross multiply here, or I could kind of see that v is going to be negative 3. If you don't see that cross multiply, 3 times 1 is 3, negative 1 times v is a negative v. To make a positive v, I would just divide both sides by negative 1, and I'd get v equal negative 3, okay? So when my actual real solution point has a u in it and a v, and remember, we always write those things in alphabetical order anyway, and what I just got for v was negative 3. So now, if you remember x, we found out that x was equal to a half, right? But wasn't x also equal to 1 over u? Now you can look at those and see that u is going to be 2. If that's not as obvious to you as it is to me right now, we'll cross multiply and solve for u. U times 1 is u, and 1 times 2 is 2. Oh, u is 2. There's my solution. So what was going on with this problem? Well, what was going on with this problem was this really is not a linear equation. It is what we would call a rational equation, which we're going to study later this year. Sometimes we can play little math substitution tricks like this and actually figure out what these answers are. Even though it's not a linear equation, I could rewrite it like they told us to do. They kind of told us what to do here. I could rewrite it like they told us to do, and then I could actually find the answers just by using substitution and then going back and unsubstituting, if that makes sense. We were actually able to figure out what this was using the idea of linear combinations, and we were able to figure out something for a rational equation. So that's how, your math tools can sometimes be used in very interesting ways, and this is a good example of it.